Hello guys, it's 9 a.m. So let's get started. Let me share my screen. So let's have a recap of on what we have covered last week. Last week we talked about data type. So there are a few data types in C++. There is integer. Integer is an integer type as in a mathematical form is an integer, and there's floating point, which is a decimal number in mathematical notation. So also we have double floating point. Double floating point is actually very similar to floating point, but it can store more precisely. It can store more information. So it can store a longer decimal number. Also, there is character type. Character type is actually an ASCII character. So last week we searched online, right? So character type is actually from ASCII code. So if you're interested, you can check which number or which character or which alphabet is supported in character type. So these are all the supported character in the character type. And Chinese character or other kind of characters which is not in this table are not supported in the character type. And also we talk about string. So string is a very powerful thing. You can store any kind of characters here. You can store Chinese or Chinese, English, Korean, Japanese, anything. So you can store anything here and you can process it. So this is very powerful and very useful string. Always when we are many times when we are debugging, we'll print out some sentence, some word for debugging, for visualizing thing, right? So we print out a string. So this string is very helpful in debugging as well. Also, there is a Boolean type. So in Boolean type, basically they store two things on it, either true or false. So they store either true or false. We will cover more on this today, actually, on Boolean type. And this is a conclusion of what is supported in C++, the basic data types. And also we talk about cin. Cin is for input interaction. So cin is from is something like a function and it's written by some other guy. For example, this function is stored inside this IOStream library, and we just import it, we use it, and now we can interact with the physical life. So for example, you can, by using cin, you can key in something from a keyboard and your computer will be able to intercept this signal and process it. And now the characters you type in your keyboard is being stored inside this, for example, stored inside this variable X. So cin allows us to interact, allows our program to integrate with the real life. It's very powerful and very useful. And we talk a little bit about debugging. Debugging is a very valuable thing that you need to know. So how can you debug? You can look at the error message being thrown in the console, in the terminal, or you can try to print out something to give you a visualized hints on what's happening. And these are some methods to debug. There are much more methods to debug as well. These are just some example. So today we are entering to chapter 2. And as a quick recap, in chapter 1, we talk about header. Header is a preloaded programming function. So this is a header. What does this header do? So by using this include, we are including a library which is written by others. And this library might have a lot of useful functions which we can use it in our program. So this is a very helpful thing. And then there is variable. So variable is a namespace which is used to store data. So for example, when we call the cin function, cinput, we read something from our keyboard. We have to store it somewhere, right? We have to store this data somewhere. So we can store it inside a variable. And after we store it inside a variable, we can process it. And there is data type, which we talked about it just now. And there is we talk about equivalent also. So this equal function, equal symbol. What does this equal symbol means? It's different from what it means in mathematical form. In maths, equal means equivalent. We are comparing something in maths, equal. But in C++, equal means assignment. For example, it means you are assigning a number to a variable. Okay. And however, if you want to do equivalent comparison, you have to make it double equal. Double equal means equivalent. So double equal in C++ is like the single equal in mathematical expression. And for input and output, so always to use the C input and C output. And yeah, that's it. So let's start this chapter 2. In chapter 2, we'll talk about arithmetic operation and conditional statement. So today's lecture will cover arithmetic operation and conditional statement will be for next week. Okay, let's see what is arithmetic operation. Arithmetic operation is actually something like mathematical operation, but it's one kind of mathematical operation. So they are doing plus, minus, times, divide. And also similar to mathematics, multiplication and division have the precedence than addition and subtraction. So what does this mean? This means, for example, here. If I have an expression integer a equal 1 plus 2 times 3. So what will be the number AB? So based on the precedent, the priority of the precedence, so times have higher precedence than plus. So we do 2 times 3 first. This 2 times 3 is 6, and then we plus 1. So this makes a 7. This is the same as mathematical expression. And then, okay, for example, let's take a look. What will be the input? What will be the output of the code below? So first, we define an integer a, and then we assign something, a mathematical expression to a. So this mathematical expression will be calculated and be assigned to a. So in this expression, here, this thing inside parentheses will be executed first. So 3 minus 4 equal to minus 1 plus 5 times 6. So times has precedence over plus. So we do 5 times 6 first. So plus 30. That means this will output minus 1 plus 30, which is 29. Let's try run it. in the playground. Yes, it's 29. And then while we are doing arithmetic operation, right? So sometimes we need to work with floating point number. That means sometimes we need to work with decimal numbers. So when you are going to store decimal numbers, you have to define a proper type for it. For decimal numbers, we have talked about it for many times. It's either float or double. So when you are trying to store decimal numbers, define your variable as float or double, as it is here. Let's look at this example. The Cyclops designed a program to calculate the value of 17 divided by a number. Please help Cyclops to complete the missing part of the code. So Cyclops have float a equals 17. And then there's something missing here. And then it should output C out 17 divide by something B equal A divide by B. So here that means, so we are trying to see out B, right? See output B. That means B have to be defined as well. Oh, that means B have to be defined as well, and we are going to see input B. This is one of the assignment in our platform. So you guys can play with it as well in our platform. But I can demonstrate it. Let me demonstrate it. We have a float integer A, and now we are going to define a float integer B. Okay, let's say we give it a value 0 first. And then we're going to input B. And then we're going to print it out. Input B, X. So print it out. 17 divided by X is 2.125. But be careful. In C++, you cannot divide by 0. What happens if you divide number by 0? You can try it. Let's say A divide by 0. We are not going to read this. It throws error because in mathematics, a number dividing by 0 give infinity. So it's the same in C++. They can get an answer because it's infinity, so they will throw error. It will throw error. And so it's a good practice if always before we do a division, we make a checking. Let's say let's refactor it a bit. For example, we can write float result equal A divide B. But then we have to have a control structure conditional statement. We have to compare. If B equal 0, okay, let's say if B not equal 0, if B not equal 0, then we store the result as A divided by B. Else, if B equal to 0, that means it's infinite. A divided by B will be infinity. So we wouldn't want that to happen. So we can return something artificially. So like say result is 0. Or we can just print out something, C out infinity. And here. Now we can print out the result. So let's try our program. What is it telling now? So it's saying that probably this is not defined. So I got a typo just now. Let's type act again. So act works fine. For act, it goes into this control structure. This is what we will cover in chapter 2 as well, the if-else conditional statement. So if something happens, you do something. Otherwise, you do something else. This is a very powerful structure. And how about we try what if b equal to 0? Let's try if b equal to 0, it goes into the else structure, the else statement, which is we're printing out infinity. Why is that so? Because if we let a divided by b, the program will throw error because this is not allowed. Okay. Okay, so something to think about. What if we use integer to perform the task above instead of floating point? For example, we have this program. So we define integer a equal 5 and float b equal 5. And then we let them divide by 3. What will happen? Let's try this. Now on playground. Okay, as you can see, when we let a divide by 3, 5 divided by 3 should be 1.67, right? But it's outputting 1. Why is that so? Because a is an integer type. After it divided by 3, still the computer stored it and processed it as an integer type. And so the decimals number won't be stored. The decimal part won't be stored. So only the integer part will be stored. And for floating point, for b, when b is divided by 3, it works fine because our program knows that, the compiler knows that b is a floating point number. And they are processing everything here as a floating point number. And thus the decimal part is still here. And this is something to be careful about. It's a very common beginner issue, a beginner mistakes that you're asking why my decimal part is missing. That's because you are doing processing in integer. Yeah, and compiler thought that you're trying to process your mathematical expression in integer type, and thus the decimal point is lost. And then there's something quite special in C++ or in programming. So we have a percentage symbol. This percentage symbol serve a very special purpose. So it's to calculate the remainder after division. What does this mean? For example, 10 divided by 3, and the remainder will be 1, right? 10 divided by 3, the remainder will be 1. So A will be 1. This remainder. And 3 divided by 3, what is the remainder? The remainder will be 0. So A will be 0. And 5 divided by 0, it throws error as we've mentioned just now. Divided by 0 is not allowed. So what is remainder useful for? So remainder is useful for finding multiples and determining cycles and identifying specific patterns. And I think you will touch more about it in our assignments or in our homeworks. So one of the usage of percentage is, now for example, if I'm asking you to design a program to determine if a number is a multiple of 4. So how can you do so? Let's say I give you a number A and I input it from the keyboard. So A is 100. How can you determine whether this number is a multiple for 4? So it's a math question actually. So you calculate the remainder of 100 of this number A of 100 after divided by 4. So the remainder, for example, if A is 100, the remainder is 0. So that means A is, which is 100, is a multiple of 4. However, if, for example, A is 99, the remainder will be something else, definitely not 0. So that means now A is not a multiple of 4. So that is one of the usage of percentage. So most of the time we use percentage this way to determine whether a number is a multiple of something. And then now let's talk about something quite tricky. So let's look at this expression, this statement first. X equal x plus 1. So let's assume x is a variable. Maybe it's an integer, a variable of integer type. So x equal x plus 1. What is this statement doing? So in this statement, we are adding 1 to x. For example, if our x is 2, 2 plus 1 will be 3. So 2 plus 1 and we will be 3, and we're assigning this 3 back to x again. So after this statement is being executed, x will be 3. So we have a program here. Let's try to run in our playground. So let's run it and format it a bit to make it look better. So initially x is 5, and then we assigning x with x plus 1. So 5 plus 1 equals 6, and we're assigning this 6 back to x. And then we print out x. So x is 6. It's simple, right? But it can get trickier. Let's go on. How about x? Okay, there's something special. So it's called x plus plus. X plus plus and plus plus x. So this x plus plus is actually a short form of x equal x plus 1. So it's a short form. In this way, you write your code maybe faster. But also at the same time, plus plus x is also equivalent to x equal x plus 1. But there is a difference. There is actually a difference. X plus plus and plus plus x are not at all the same. So what does x plus plus do? X plus plus will return x first, and then assigning x plus 1 to x. So this is a bit abstract. It's very hard to imagine, right? But later we will have some example. And plus plus x means we assigning x plus 1 to x first, and then we return x. So this is very abstract, I know. So let's take a look at the example. First, let's try this. A equal 1, and then we're trying to print out A plus plus. So this prints out 1. Okay. So why this prints out 1? Because there's the reason is this. So in x plus plus, we return x first, and then we let x plus 1 return x first. Okay, this is important. Here, this is a mathematical expression, a plus plus, but we return a first to this function. Let's say C output is a function, we return a first to it. And so it's going to print it out 1. Okay. After that, a is actually 2. If we print out a again, now a is 2. Why is that so? Because we are returning, initially we are returning a to cout function. And then we reassigning a to become a plus 1. So now a equal to 2. So this is a plus plus. How about plus plus a? Let's try plus plus a. What would you expect? So in plus plus a, we make x equal x plus 1 first. Only after that, we return x. So in our case, we make a, here plus plus a, we make a plus 1 first. And then only after that, we return a. So here, a initially is 1, right? So we let a equal a plus 1. Now a is 2. And then we are returning this 2 back to the C output function. So what will be output over this line should be 2. Yes. So it is 2. And still in line X is also 2. Okay. And so we demonstrated this already. This is the difference between a plus plus and plus plus a. Okay. And then just now we mentioned that wait, just now we mentioned that, for example, if we have integer x equal 1, x equal x plus 1 is equivalent to x plus plus, and also equivalent to plus plus x. Oh, but actually there is another short form for x equal x plus 1. The another short form is x plus equal 1. There's short form for it. And it doesn't just work for plus. It works for minus as well. So you can write x minus 1. This is equivalent to x equal x minus 1. These two are equivalent. How about time multiplication times x equal x times 2 is the same as x times equal to. Same for division. X equal x divided by 2 is the same as x divided equal to. So this is the short form. The bottom part is the short form of the upper part. Okay, so these are all the supported short form. Plus equal, minus equal, times, divided by, and remainder. And we have a kind of a conclusion here. So plus operator, there's a list of operators. Plus operators is for addition of two operands. For example, 18 plus 2 will be 20. Subtraction is the same as in maths. So 18 minus 2 is 16. And times and divide is the same in maths as well. And remainder is a bit special. We seldom see this in mathematical expression, but we use it frequently in programming in C++. So it's for calculating remainder. So 18 divided by 4 will be the remainder after 18 divided by 4 will be 2. So this is the remainder. Also, we have a notation for positive numbers. To indicate positive numbers, you can type a plus 100, or you can just ignore this plus. Just type 100, and this will be a positive numbers. However, for negative numbers, so it's the same in maths. You write minus in front of your number. So for example, here, you can define your x as minus 100. So now your x will be a negative number. And plus, there's also plus, plus, and minus, minus. Plus, plus is actually the short form of a equal a plus 1. And minus, minus is actually the short form of a equal a minus 1. So plus, plus increment your number by 1. And minus, minus decrease your number by 1. And next, we are going to talk about relational operator. So other than these basic arithmetic operators, which we have just covered, there are many other operators. For example, there's greater than. So what is this greater than for? So this is for comparing your number to check whether a number is greater than another number. For example, whether x is greater than y. Let's say our x is an integer and with a value 1. Our y is an integer with value 3. Now we want to compare it. If it is greater, we execute some of the programs, and otherwise we execute some other parts of the programs, something like that. So this is for comparison. So we have greater than, lesser than, greater than or equal to, and lesser than or equal to. Also, we have equal. This is checking, comparing whether x is equal to y. And also we have not equal. So that means we are checking, we are verifying whether x does not equal to y. Okay. And we have mentioned it many times already. Equal and equal is different. Equal is for verbal assignment, while double equal is for comparison. So this is double equal. Finally, we get to see it. And what is the output of relational expression? This might be a question in your mind. So the output of a relational expression will be a Boolean. Why is that so? It actually makes sense because we are comparing something. So it's like I'm asking you a question. Is x greater than y? Yeah, so in response, you tell me it is true or it is false, right? It's the same for x equal. If I'm asking whether x is equal to y, so you are going to give me an answer which is like true or false. It is or it is not. So this can be captured in Boolean form. So this answer can be captured in Boolean form. So the answer for this for this operator, for this kind of operators, they are outputting a Boolean number. Sorry, it's not a Boolean number, a Boolean type. And we talked about it a few times already. Booleans represents true or false. And if it is true, when you try to print this out, it will be 1. And it is false, when you try to print this out, it will be 0. Okay. It is used to indicate true or false, or correct or incorrect, or presence or absence. So we have an example here. So first we have a Boolean type A, and we are assigning true to it, and then you're trying to print it out. So what will the output be? Maybe you thought it will be true, right? But it's not. It will be 1. Let's try this. So it will be 1. And so as you can see here, true is 1 and false is 0. Okay. And for example, how about this code? We have defined a Boolean type B, and then we're assigning something to B. What are we assigning? We're assigning a mathematical expression, and this expression calculated to something, right? So this 3 greater than 5. 3 greater than 5 is false. So this return false to B. And thus B should print out 0, because false indicate is equivalent to 0. Let's print this out. Yes, so B is 0. And so there's a note here. It will be always true when the value is greater than 0, no matter what is the number. What does this mean? So I think this means that, for example, how about you assign B equal 1? And you print it out. It will be 1, right? But how about you assigning B equal 2? It will still be 1. Because 2 is true. Any number greater than 0 is considered true. For example, 100, 1000. Still is considered true. But if you make it 0, this is considered false. When 0 is stored in Boolean type, is considered false. How about -1? -1 is considered true as well. -100, 1000 is considered true as well. So that means other than 0 indicate false, all the other numbers indicate true. Okay. That's something to note about. Let's look at this example. So what will be printed out? So here A equal 5, and our comparison is A smaller than 5. So this is incorrect. So this will print out 0. How about this? B equal 5. 6 equal 5 is not true. So this is false. So this will print out 0 as well. How about C not equal to 6? C is 7, so it's not equal to 6. This is true. So this will print out 1. And yeah, this will print out 0, 0, 1. How about this? Let's look at this example. A greater than B. 3 is greater than -5 is correct. So in C++ or in C++, so it's the same as maths, really. A positive number is greater than a negative number. So it's very intuitive. So 3 this is true, which is 1. And then true equal B. So just now we demonstrated -1 is converted into true as well. So this is true. And C not equal to false. 7 will be converted into true. So true not equal to false, which is True. So this one is true as well. And B smaller equal than C. So this is true. Looks like all of this is true, or is it? It is not. True equal B. This is 0. Let's try to run this. And why is that so? So 1, 0, 1, 1. This is true. This is false. This is true. This is true. Why this is false? So true equal B. So I think when we are doing this kind of comparison, so true will be converted to 1. And we are comparing whether 1 is equal to -1, which is not. So this gives us false. Okay. And also back to this, C not equal to false. So false will be converted into 0 during comparison. So 7 not equal to false is true. 7 is not equal to false. It is true. Okay. And then also there's another kind of operator. It's not arithmetic operator now, it's logical operator. So what is this logical operator for? So it's mainly to be used on top of a Boolean type. In Boolean type, we indicate something is with something whether it's true or false. So we can do calculation or like logical calculation of these Boolean types as well. So if something is true, you want to verify it or do checking on it, can put on top of it a not symbol. Not means not. So if you apply not on the true, it will become false. If we apply not in front of a false data, a false Boolean number, it will become true. How about n? So let's say x and y are both Boolean data type. So now we are comparing. If x and y are true at the same time, then this calculated to true. If one of x or y are not true, then this calculates to false. Also, there's or. Or means either x or y need to be true. So either x is true, this will calculate it into true. Or if y alone is true, this will be calculated into true. Or both of them are true, this will be true as well. For logical not, so if you apply not in front of a Boolean number, it will become false. Let's look at an example. Let's say we have a Boolean A equal false. Let's say equal true. Equal true. And we see out not A. Is this allowed? I seldom do this, so let's check. So it's allowed. So we print out not A, which makes A false. So A is false. Yeah. And then there is logical AND. For logical AND, that means both value need to be true in order for the output to be true. For example, a vehicle needs both petrols and car key to start the engine. That means if we have to have both things. Both have to be true in order for this expression to be true. Yeah, okay. So let's take this as an example. Let's say we print out V, V, vehicle and start. Let's has pet, petrol equal true, and boolean has car key equal false. And boolean can start means we have to has petrol and has car key at the same time. If can start, we print out can. Otherwise, we print out cannot. And then we print out starts. End of line. So it's throwing error here. Probably I should wrap this parentheses. So it's telling that vehicle cannot start. Don't worry if you can't understand this syntax right now. So I think we covered it in the same chapter. This is something to do with conditional statement with a control with conditional statement. So this actually means if can start is true, then we're going to execute this statement. Otherwise, we are going to execute this cannot statement. So if can start, we return this can to the C output. If cannot start, we return this cannot to the C output. So it will be printed out. If both are true, so vehicle can start. This is something about N. This is a demonstration about N. So for R is actually similar to that, but the calculation is different. For R, for example, you need an umbrella or a raincoat in a rainy day. So that means either of the condition is true, this expression will output true. Let's say A is true and B is false. This will output true because A is true. Either of them is true. It's enough for it to output true. And where is not and this or? So not is here. This is for not. And N is here. And or is here. Let's execute the code and observe the output from the code. Later, when we are looking at the assignment or homework session, we'll take a look at this. What will the output from the code below? A and B. B and false. C or not A, not B or false. So you can try to run it in, let's try running in the playground. One zero one zero A and B. So 3 calculated to true. -5 also calculated to true. Why are they being calculated to true? Because AND operator works for Boolean data type only. So the value between this and operator have to be converted to a Boolean number first. So A will be 1, -5 will be 1, and 1 and 1. 1 means true. True and true equals true. So we output true, which one? How about B and false? B is true. True and false equal false. And thus, it will output 0. How about C or not A? So first, what is A? A is 3, right? So 3 will be converted into true. Not A means not true. Not true will be false. So C is 7. 7 will be true. True or false? Because there's a true here, so this calculated into true. How about this? Not B. So what is B? B is -5. -5 can be converted into true. So not true will be false. False or false will still be false. So this output false, which is 0. And then we're going to talk about operator precedence. What is operator precedence? We touched a little bit about it just now. So for example, times and divide has higher precedence than plus and minus, right? And how about, but we introduce some more operator, for example, greater than, not, and this, and what is their precedence level? So we actually have rules for it in C++. So parenthesis first, and then an assignment last, and operation before comparison. These are not a very helpful note. Always parenthesis first. Here, this is an assignment last. This is actually the same as mathematical expression. In a mathematical expression, if you have something like this, 1 plus 1, 2 plus 3. So parenthesis will take precedence. We will calculate 2 times 2 plus 3 first. And then only after that, we let 1 plus the answer, the output of this, which 5. So this becomes 1 plus 5, which becomes 6. Right, that means parenthesis takes the highest precedence. And then assignment takes the last precedence, which means only after we calculated everything here at the right-hand side, then we assign this to A. So the output is 6, right? So we assign 6 to A. So here, parenthesis first, assignment last, and operation before comparison. What does this mean? This means we have to calculate, for example, here, if we look at this, we have to 4 divided by 5 greater than 7. We are going to calculate this first before we're doing comparison. So we compare this and this. And there's a sheet on this. Parenthesis first, and then there's some this logical notes, increment, decrement, something like this. Parenthesis first and assignment last. And here this code is not that readable. So the best practice for this, when sometimes you're going to write a lengthy code or a lengthy comparison like this, always the best practice is to cover it, to wrap it in between parentheses. For example, 3 plus 5 and 4. It's better to wrap it around parentheses to make your code clearer. Okay. This is just a sample. So something like this. Or even better, if you could split it, if you could split your expression to make it less lengthy and more readable. This is even better. So this will be B. And result equal A and B not equal to not 4. And let's say there's a C equal not 4, not equal to C. And let's say there's a D equal B not equal to C. So see, it's much clearer now, and you can always split your mathematical expression. You can split it and store it in another variable. That way our code will look clearer and it's easier to understand and to maintain. So there's an explanation here. So because equal has the least precedence, and we are going to execute this first. Not really, this part first, not really. Because I think times text the precedence, or not text the precedence. So not 5 will be calculated first. And then times tag precedence before this comparison operator. So you do a times first, it will be 0. And then still plus text precedence over greater than. So we plus it first, it will be 3. And then this greater than operator text precedence over equal. So we calculate this first. Plus, so on and so forth. We get our answer. We get to our answer. But this is bad code actually, because it's not readable at all. And yeah, we shouldn't write code like this. And this is all about today's lecture. Let's have a 5 or 6 minutes break. So we'll start again on 10:05 a.m. So on 10:05 a.m. we'll talk about assignments and some homework questions. Let's take a break and see you all guys at 10:05. Okay, it's 10 or 5 now. Let's go through the classroom exercise and homework together. So there's a question. To find the output of the given code, let's analyze it step by step. We define an integer a, and then we assign mathematical expression to a. So this mathematical expression will be calculated. And remember, parentheses take precedence, right? So 3 minus 4 will be calculated first. And then 5 times 6 will be calculated next. And then this will be added together. And this will be 29. Okay, how about this? So actually we demonstrated this just now. Cyclops designed a program to calculate the value of 17 divided by a certain number. Please help him complete the missing parts of the program. So this is actually a fill in the blanks question. So what we are going to fill in is that we have to define a float b first, and then we have to read a verb. We have to read it. We read this variable b, and then we calculate and print it out. And then one thing to take note about is that b cannot be 0. If b is 0, is will throws error. So careful of this. So save form, submit it. And how about this? Cyclops wants to design a, oh, sorry, 1 minute. Okay. Cyclops wants to design a function that can determine if the entered number is a multiple of 4. Please help him complete the entire program. So for this, we can use remainder. So as we have talked about in the lecture, remainder return the remainder after division. For example, if a is 100, 100 divided by 4, the remainder of 100 divided by 4 will be 0. So C will be 0. Okay. You can try around it. So for example, 100. If it is 100, this will be executed because C equal to 0. The remainder of 100 divided by 4 will be 0. So this will be executed, as you can see here. However, if it's something like 99, 99 is not a multiple of 4. So this is one of the this is a use case of percentage. And as you can see, there's a if and else conditional statement, control structure here. This will be covered in chapter 2 as well, but will be covered in next week lecture. Okay, let's submit it and successful. How about this? So we have A equal 3, B equal -5, and C equal 7. Is A greater than B? 3 is greater than -5, so it's true, and true is printed out as 1. How about true equal B? So true will be calculated to 1. And 1 equal B, 1 equal -5 doesn't equal. So this will be false, which will be 0. How about C? C not equal to false. C is 7, not equal to false. False is 0. 7 not equal to 0. This is true. So it's 1. How about B smaller than C? B is -5. It's smaller than C. C is 7. So this is true as well. So this true is printed out as 1. Let's submit it and Okay, it's done. And let's look at this example. Let's try running. What is printed out? Not 1. Not 1 will be 0. And not 0 will be 1. Why is that so? Because 1 is converted, is considered as a true Boolean. So not true will be false. So false will be printed out as 0. Oh, this 0. 0 is considered false Boolean. So false, not false will be calculated into true. And true will be printed out as 1. How about 1 and 1? That means true and true. True and true equal true. Okay. How about true and false? True and false equal to false. False and true equal to false, and false equal to false as well. So you can see a pattern here. That means only if both condition is true, then the output of this AND operator will be true. So both of these must be true at the same time. How about OR? 1 or 1 equal 1. 1 or 0 equal 1. 0 or 1 equal to 1. And 0 or 0 equal to 0. So also you can see a pattern here. If either of the left side or the right side is 1, that means either condition is true. This calculated into true. Okay. And if both are false, this calculated into false. And I suggest you to actually some kind of either memorize or you have your way to remember it. You have to, it's important to remember this kind of pattern. It's very useful, very, very, very helpful. And we will work with them a lot in if and else. This kind of conditional statement or conditional structure. Based on the provided code, here's the analysis. So what is A and B? A will be calculated into true and B will be calculated into true as well. Why is that so? So we demonstrated this morning. Every number will be converted into true except number 0. Except 0 is false. Any other number are considered true. So A is true and B is true. And thus the output is true. Thus, which is 1. And B and false. B will be true. True and false will be false. Why is that so? Because in order for the AND statement to be true, both of the conditions have to be true. And there is already a false condition here. So this will be calculated into false. False is 0. And C or not A. Not A. A is 3. 3 is considered true. So not true will be false. How about C? C is 7. 7 is true. So true or false? True or false will be calculated into true. How about not B or false? Not B. B is -5. -5 converted into Boolean is true. So not true will be false. False or false will still be false. So it will be 0. And let's submit this. Well done. Okay. Please design to allow the user to enter a number. If the input is 7, display I am great. If the input is any number other than 7, do not display anything else. So we haven't covered on this yet, but actually we can walk through it a bit like learning by doing. So for this question, we have to read it a number. If this number is a 7, we're going to print out something. So as you can see, it's very simple. For compare, so we have a control structure here, a conditional state structure. So here we are checking if number equals 7, we print out something. So this if is a preserved keywords in C++. It serves a special purpose. So it's for checking whether something is true. If this is true, then everything inside this braces will be executed. How about you say, if this is not true, how about that? Then we can try. Then another condition can be executed. Else, I'm super great. How about that? And we can run this. If this is 7, I'm great. This will be run. If it is like 17, I'm super great. The else condition will be run. So if you don't understand any of this, don't panic because we'll cover this on next lecture. Submit and it pass. Also, another question is asking for similar thing. If n greater than 0, print it mil. Otherwise, print it bread. So if n greater than 50, print out something. Otherwise, do something else. So you get the idea. This is the if-else control structure conditional statement. Oh, sorry, what is that called actually? It's called if statement. So this is an if statement. Submits and it pass. How about this? If n greater than 50, print it mil. If n greater than 30 and lesser than equal than 50, print it break. Otherwise, print not enough. So here we introduce another new thing. It's called else if. If something is true, we execute this part of code. Otherwise, if this condition is true, we execute another part of the code. Otherwise, if none of the above match, we execute this part of the code. So you can add as many else if as you like. So maybe you have another kind of condition. N equal 20. Then do something. N equal if n equal else if n equal 21. Do something. So you can have a lot of conditions. And for each of the new conditions, just add an else if in between. It's okay if you submit it. Pass. So this is telling that if a greater than b, print a greater than b. Else if a lesser than b, print a lesser than b. Otherwise, a equal b. So we do exactly the same and pass the test case. And also there's this. So okay, we'll cover more on this on the next lecture. And there's also a demonstration of how much space a kind of data type is taking. I think we'll cover more on this on next lecture as well. So for Boolean, it's taking 1 byte of space. And let's take a look at float and double. So float is taking 4 bytes of space and double is taking 8 bytes of space. That's why double can store longer decimals than float. So you get the idea. Don't worry if you don't understand. We'll talk about it next lecture. And okay, this. So let's take a look at this. A equal 3 and B equal 2. Now we're going to print out A plus B minus minus. This is a bit tricky. So what will the output be? So remember here, A plus plus, return A first, and then we let A equal A plus 1. Okay, remember this? Now, A plus plus, return A first. So return 3 first. B minus minus also is the same. Return B first. So it's 3 plus 2, which will be 5. 5. But after that, after A is being returned, A equal A plus 1. So on next line, if you are going to print it out at on next line, we have A equal 2, B equal 3, and we print out A plus 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 B minus minus. Is there a typo? Oh, because I'm using Python. So this is 5, right? And A plus 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 B like minus minus. Okay, it's correct. And then later, afterwards, if we print out A, what will it be? It should be 3. And if we print out B, what will it be? It should be 2 because it is being decreased. So there's a typo over here. So see, it's telling that there's something happened to N now, basically. So as you can see, A is 3 now, and B becomes 2 now. Submit it. Next. How about this? What's the final output result? A equal 3, B equal 2. 1 minus A plus plus times B. Oh, this gets trickier. So remember, A plus plus means we return A first. Only after return A, we increase A. So A, this is like A times B. A is 3, B is 2. 3 times 2 will be 6. 1 minus 6 will be minus 5. So the first one will output minus 5. After that, 1 minus plus plus A times B. So what is this doing? That means we increase A first. Only after we increase A, we return the A. So after A plus plus A is now 4. So here, plus plus A. A is 5. 5 times 2 will be 10. 1 minus 10 will be minus 9. So if you are still confused, let's demonstrate it in the playground. Let's run this first. I'm going to output A and B. Initially, A is 3, B is 2. Wait. Initially, A is 3, B is 2. And format it a little bit. And then here the answer is minus 5. But then right after this calculation, because of A plus plus, A is now 4. A is now 4. B is still 2. And in line 12, after this expression, after this calculation, A is now 5, B is 2. So I hope you get the idea. Submit it and it's correct. Integer A 5, B, C, D. A equal 4, B equal A, C equal B plus plus, D equal plus plus B. Based on the above program description, what are the final values of A, B, C, D? So this, initially we give a value of 5. So this is a short form of a integer A equal 5. So we initialize A as 5. But then it will assign A equal 4. So now A is 4. And then we assign A to B. So now B also is 4. And then we assign B to C and B plus plus. So C also is 4. Okay, C is 4. And B plus plus. Previously B is 4, right? So B is 5 now. B is 5. And we assign plus plus B to D. That means we increment B by 1 and then we assign it to D. So B is 5 over here. Now B is 6 over here. And we assign it to D. So D is 6 as well. And B will be 6 as well. And A will remain 4. So let's submit it. And well done. And there's a question about Cyclops wants to eat apple pie. It is known that each 5 apples can make 1 apple pie. Today, Cyclops bought n apples. How many apples will he have left after making the apple pies? So this is actually a remainder question. After you divided all the apples by 5, what are being remains? And thus, the remaining apples is simple. Just get to calculate the remainder and print out the remainder apples. These are the apples that will be left after he made all the apple pies. Let's submit this. Let me pass. So there is no more exercise. And thus we have covered all the relevant exercises and homeworks for this lecture. Next week, we'll talk something more interesting. We'll talk about if statement. And probably we'll talk about switch case. Is there a switch case? We'll talk about type conversion. And we'll talk about binary number. Oh, we'll cover quite a lot of things. So next week will be quite exciting. And yep. So that's all for today's lecture. Thank you guys. See you next week. Bye bye.